Hello class, today we'll be covering how to conduct a hypothesis test to compare two variances. To do this, we'll be going in section 9.4 number 1. It has been suggested that night shift workers show more variability in their output levels than day workers. Below you are given the results of two independent random samples, and it's given here. Make sure you do write this down. Now class, you will not have any homework assignments in my math lab with what we're covering today, but do try to do section 9.4 number 2 in the notes just for practice, and the notes are completed so you can check your work as well. So start off, we're going to make a hypothesis just like we normally do. We have h naught, h sub 1. Now h naught always has an equal to sign, but we don't know what we're setting equal to right now, because we have two different populations. We have night shift and day shift. So we're going to have to signify which one's which. I'm going to let night shift be population 1. It could have been 2, I just happened to choose 1. So we're going to say for the null that the standard deviation, or the variance of the night shift, is equal to the variance of the day shift. Sigma sub 1 squared equals sigma sub 2 squared. Now the alternative says that we believe the night shift workers have more variability, so that's going to be sigma sub 1 squared is greater than sigma sub 2 squared. The night shift variance is greater than day shift variance. Now that we have the hypothesis test, we can move on and do a test statistic. And by the way, that was part A, and the test statistic is part B. So we have F equals S sub 1 squared over S sub 2 squared, and this is our formula for this hypothesis test. Now, one of the key things about this is this S sub 1, it doesn't necessarily mean which one's your population 1. This one is whatever variance is larger. Your case might have been an S sub 2 instead. Just make sure the larger number goes here. So for our problem, that gives us 38 over 20, which will give me a 1.9. Now that we have our test statistic, we can move on and find the p-value. Similar to the t-table, when we look at this p-value with this f-table, we will not know the exact value, but we will know a range. We will know it's between two values. Now to read this table, we need degrees of freedom of numerator, which is df and a capital N. That's equal to 9 minus 1, the sample size of the night shift minus 1, which is 8. We need degrees of freedom denominator, which is sample size of day shift minus 1. 8 minus 1 is 7. So now we can go ahead and look this up in the F table with the degrees of freedom. Numerator is 8, degrees of freedom denominator is 7. And we find out that our p-value is between two different numbers. If we look at this, we see that the p-value would fall somewhere between 0.1 and 1. The reason why I know it's between 0.1 and 1 is because that 1.9 goes past the 0.1, and since it doesn't list any other alpha values, we're going to shoot ourselves all the way up until that 100% mark, which is 1. Now that we have a p-value, we can move on to the conclusion. We might not know what the p-value is exactly, but for our conclusion, we don't need to know the exact value. We just need to know, is it bigger or smaller than our alpha? Well, the p-value is between 0.1 and 1, which means the p-value is definitely greater than 0.05, which was alpha. And if p-value is greater than alpha, we will fail to reject H naught. Now, if you have any questions about how I got these values, remember you can message me through Blackboard. You can contact me through course messaging or post in that discussion board. Now remember what I said at the beginning of this video. I want you to try in your notes 9.4 number 2, and feel free to ask questions in the discussion board about how to do this. It's not for a grade, but you will need to know how to do these problems for the test.